Hi, I am Dr. Eli Kohlberg from Unlimited Robotics, and in this video I will talk about electrical charge. In a regular situation, the number of electrons is equal to the number of protons in the atom. It means that the atom will look as uncharged. In order to create an electrical charge, there is a need to gather many electrons in a substance in order to create a negative charge. It is possible to create electrical charge by rubbing one material against another different material. It will cause a transition of electrons from one material to another. Let us assume that the electrons move from the first material to the second material. In this case, the number of protons in the first material will be bigger than the number of its electrons, which will result in a material with a positive charge. The second material to which electrons were added will have a negative charge. For example, rubbing a fabric against copper rod will create a movement of electrons from the fabric to the copper rod. The copper rod will have a negative charge since it gained additional electrons while the number of protons has not changed. The fabric will have a positive charge since electrons exited to the copper rod and now it has more protons than electrons. A phenomenon related to the electric charge is that charges with identical signs repel each other and charges with opposite signs attract each other. We will designate charge with the letter Q. The charge unit is Coulomb. A charge of 1 Coulomb is equal to a concentration of 6.28 times 10 to the power of 18 electrons. Therefore, the charge of a single electron is Q equals to 1 divided by this number, which is equal to 1.6 times 10 to the power of minus 19 Coulomb. Coulomb law enables calculating the force between 2 point charges. The term point charge is related to the fact that the size of the charged particles is very small compared to the distance between them. As we already mentioned, there is a repelling force between charges with the same sign and attracting force between charges with different signs. Next figure presents two charges, Q1 and Q2, with a distance r apart from each other. French physicist by the name of Charles Augustin de Coulomb measured in the year of 1784 the force between two static point charges and came to a conclusion that this force is inversely proportional to the distance between the charges and is directly proportional to the multiplication of the charges. The Coulomb law derived from the above observation is Fe equals Ke times Q1 times Q2 divided by r squared, where Fe is the rejection or attraction force between 2 point charges. Sometimes it is called electrostatic force. Force units are Newton and designated by the letter N. Ke is the relation constant, or sometimes called Coulomb constant, and its value is 9 times 10 to the power of 9. It is also equal to a quarter times pi times epsilon 0, where epsilon 0 is the dielectric coefficient in a vacuum and is equal to 8.854 times 10 to the power of minus 12. Q1 and Q2 are charge points with charge in units of Coulomb that electrostatic force acts upon them. R is the distance between charges and meters. When the charges has the same sign, the calculated force will be positive and it means rejection. When the charges has an opposite sign, the calculated force will be negative and it means attraction. Example. 2-point charges with a charge of 1 coulomb each are located in 1 meter apart from each other. What is the size of the rejection force between them? Answer. According to the given data in the question, Q1 equals Q2 equals to 1 coulomb and R equal to 1 meter. We will substitute the given data in the equation. To the equation, Fe equals Ke times Q1 Q2 divided by R squared, and it gives us 9 times 10 to the power of 9 Newton. The resulted force is quite big and is equal to the weight of approximately 2,000 aircrafts. It stems from the high charge values presented in the question. Actually, the charge values are in the order of 10 to the power of minus 9, which can be designated as nano coulomb, or sometimes 10 to the power of minus 6, which can be designated as microcoulomb. Question. 2-point charges are charged with identical charge of minus 4.5 times 10 to the power of minus 9 coulomb each. The charges are located in a distance of 53.8 centimeters apart from each other. What is the size of the repelling force between them? Answer. According to the given data in the question, Q1 equals Q2 equals minus 4.5 times 10 to the power of minus 9 coulomb, and R is equal to 53.8 centimeters, which is 0.538 meters. We'll substitute the given data in the equation. Fe is equal Ke times Q1 times Q2 divided by R squared. After substituting all the data, we get that the force will be 6.2975 times 10 to the power of minus 7 Newton. The sign of Fe is positive, which means repelling force. Question. One of 2-point charges is charged with a charge of minus 7.5 times 10 to the power of minus 6 coulomb, and the other is charged with a charge of plus 2.35 times 10 to the power of minus 6 coulomb. The attraction force between the two charges is minus 0.0532 Newton. The minus sign indicates that it is an attraction force. What is the distance between the charges? Answer. According to the given data in the question, Q1 equals minus 7.5 times 10 to the power of minus 6 coulomb. Q2 equals to plus 2.35 times 10 to the power of minus 6 coulomb. And the attraction force between the two charges is minus 0.0532 newtons. We will substitute the given data in the equation. Fe equals Ke times Q1 times Q2 divided by R squared. And we get that the distance between the charges are 1.726 meters. Thank you very much for having with me. I hope to see you in the next lecture. Bye bye.